Today I am going to discuss an important topic of quadratic equation, which is nature of roots of a quadratic equation with examples, part 1. As we know that roots of a quadratic equation ax square plus bx plus c is equal to 0 are given by quadratic formula as follows. In above equation, b square minus 4ac is equal to 0 is called discriminator and denoted by d. So this becomes equation 1. Equation 1 is used to define different nature of roots of quadratic equation, such as I am going to make a table to understand nature of roots. We have 5 cases of different nature of roots which depend on the differences in discriminator. If the discriminator d is equal to 0, roots will be real and repeated and equal. If discriminator is less than 0, roots will be complex and distinct. Likewise, if discriminator is greater than 0, roots will be real and unequal. Similarly, if discriminator becomes a perfect square, which is case 4, the roots will be rational. Likewise, in fifth and last case, if discriminator is not a perfect square, then the nature of roots will be irrational. Here I am going to solve an example to check in which category the roots of this equation lie. Here example is that discuss the nature of roots of following equation: x square plus 2x plus 3 is equal to 0. To solve it, we compare this equation with standard quadratic equation, and we come to know that a is equal to 1 and b is equal to 2 and c is equal to 3. Now we use the discriminator formula to find the value of d. Now using equation 1, we can find the value of d easily, which is the discriminator of this equation, this quadratic equation. Four into 1 into 3 which becomes equal to 4 minus 12, and D comes minus 8. D is equal to minus 8. So D is less than 0. As we come to know that the value of D is minus 8, which is less than 0, so the roots of example 1 are complex, imaginary and distinct and unequal. So this category lies in case 2. The roots of example 1 lies in the category of case 2, where D is b square minus 4ac is less than 0, hence the roots of example 1 will be complex, imaginary and distinct and unequal. We can prove this statement that the roots of example 1 are complex, imaginary and distinct and unequal by using the quadratic formula. Now we will find the value of x, which will be the roots of example 1, to check whether the roots are complex, imaginary or not. As we know that the values of a, b, c are given here, we can find the value of x easily by putting the values of a, b, c in quadratic formula. So I wanted to verify the result, as I found earlier that d is less than 0, which is minus 8, and the roots will be complex, imaginary and distinct unequal. Now we can see it after a little explanation that using quadratic formula I put the values of ABC in this formula, and then I got minus 2, and as you know that b is equal to 2, so b square is equal to 4, and 4 into 1 into 3, as we know that c value of c is equal to 3, so here comes 12 at the place of 4 a c is equal to 12. So as 4 minus 12 becomes minus 8, as we know that iota is equal to under root minus 1, so minus under root minus 1 is replaced by iota, and we take common from above numerator, and 2 is cancelled here, and here we see that we have two roots. Sorry, I missed here iota term. So we can see here that I found the roots which are complex because iota is involved in these two roots, and these are imaginary, and these are distinct and unequal because one root is minus 1 plus under root 2 iota, and second root is different by the symbol of minus, which is minus 1 minus under root 2 iota.